Okay, so this is sort of graduate level, and a little bit quirky uses of point cloud. So this is the next material is sort of bonus.
Yes, yeah. Lots of our customers ask whether we could make raster histograms, and we really would like to work on that, and I believe eventually we will have them. But for now, we don't have any raster histogramers transformers, so I made a workspace, not a very complex one, which makes a nice histogram. Basically, it just splits the point cloud into thin 1 meter high point clouds, and then we just count how many points per each point cloud we have and build a diagram with Google.
Wow. Okay.
With Google, how is it called?
Google Charts.
Google Charts. Yes.
Yes. Google Charts API.
Should you run this?
Yeah. If you have it handy.
Yes, I do. Extra one.
Extra bonus. So probably we wouldn't recommend people do this, but it is an example to make you think about the kind of things you can do. So Dimitri basically splits. The key thing is to first of all turn the raster into a point cloud, which is easily done with that point cloud combiner, and then to split it into a different point cloud for every elevation value.
And we can check this. Should we show this?
Yeah, let's take a look at that in the data inspector. So that's a CSV file, and that's something a little bit new in FME 2013. Is we've got field names there. We say OK. It'll run, and then we can look at that, we have a table view now. So that's a very nice thing about FME 2013, being able to deal with non-spatial data in that way. And so there we get basically the count of the number of points for every elevation. Yeah. Okay, so that's one non-standard odd use of point clouds, but it maybe will get you thinking about some other things you might be able to do. And this one here is pretty wild, Dimitri.
Just a couple of weeks ago, a customer asked whether we could split or clip any arbitrary polygon into pieces of equal areas. So, and with some thought, I was able to do that. So within 5%, we made that possible.
It is, yeah. So it's
I can open that workspace and show you the intermediate result, the point cloud.
And so this is because inside of one transformer, there's the ability to create point clouds out of area features. And which one is that? This one. So the point cloud coercer, we're feeding it an area we want a point cloud out. And so then the key thing is that top parameter that says output geometry, spatially equal areas for multi-points. And that does the right thing.
Is it running?
So it's basically generating points, and then you must fit a convex hull or a concave hull.
I can turn off areas, and you can see these point clouds.
Right. So it made point clouds, sprayed them into the area, each point cloud covering the same area, and then you just fit a boundary around them.
Yes. Yes. The rest was just cleaning those point clouds, making
so
polygons.
Again, pretty unusual use. We probably don't know that you would necessarily use that directly, but again, may spur some creative juices and some creative thinking.